you, and welcome to my session on deploying Sitecore to Azure Kubernetes. And indeed, we've got some Docker involved here, but we're mainly focusing on Kubernetes for this talk, and then Azure Kubernetes services. My name is Rob Habraken. I'm a Chief Technology Officer and Technical Consultant at WIAU. And I've quite a lot of experience in Sitecore, and next to that, I'm mainly focusing on Azure and DevOps, and not only DevOps as a tool, but also mainly as a methodology. You can find my blog on robhabraken.nl, and I'll post about my talks and about my findings in the Sitecore area now and then. So let's first have a look at the session overview of what I'm going to show you today. I did a talk a while back at the virtual dev day of Sitecore, and I explained in that talk what Kubernetes is and how to set up your initial provisioning for Azure, and then mainly focusing on a production environment type setup. That brought us a nice environment for us to start on, but we didn't have our custom solution. So that is what we are going to do today. We're going to look into how to deploy your custom Sitecore solution to your Kubernetes cluster, and we're also going to have a brief look at deployment strategies. And why are we doing this? Well, Kubernetes is a whole new world, and it's kind of a steep learning curve if you're new to it. But things are changing in the cloud landscape, and well, let's have a look why. The most prominent change is that Sitecore is adopting cloud containers as their cloud technology of choice. They will stop providing the ARM templates on Azure and the Sitecore web deploy packages, as we've seen them for the recommended Azure PaaS infrastructure. Initially, by the way, this was planned for version 10.2 and up. They're probably going to keep supporting this a little longer, but still the focus lies on containers. By the way, Sitecore will stop providing these templates. They do not stop supporting web apps at all, but you might want to already start digging into the container realm to get familiar with that before this happens. And there are some more changes, because application insights will no longer be part of the setup as it was with ARM, so monitoring is not involved. And also, Azure Search is already being deprecated, so Solr is the new recommended search engine. And the reason for this, or at least the advantages of this, are that we now have a freedom of choice. There's no vendor lock-in from Sitecore on Azure anymore, and we are now able to reuse our setup across different platforms across different cloud providers, but also your development environment is way more similar to what you are deploying, because you're working in containers in both areas. The Kubernetes setup is, in the end, a little bit easier to maintain than the ARM scripts we had before. And there's more of a focus on the core product from Sitecore, so the adjacent setup is really up to the partner, to us, or to the customer. That means that things like SQL Server and like the monitoring, as I told you, but also Redis and stuff, is not included in the standard templates or setup anymore. You have to arrange those yourself. So we looked last session, I went through this whole slide and explained all the bits and pieces. I'm not going to do that again right now, but for anyone new to Kubernetes, I reckon it's a good thing to have a brief overview of what it is. Kubernetes is an open source container management orchestration tool, and it really helps you in deploying your containers, but also managing things like scaling and load balancing. It allows for automated rollouts, and it is self-healing. So it is there's relatively little management involved. And on top of that, we have the Azure Kubernetes Services, AKS, and that's what I'm going to look at today. Obviously, you can run Kubernetes in other clouds as well, or you can set up your own Kubernetes cluster. But for me, coming from the Azure Web Apps implementation, I really like to stick to Azure, and I also am going to share what I know and what I see and what I do related to the Azure cloud. So AKS is a fully managed Kubernetes service. It's kind of a serverless approach to Kubernetes. Storage and infrastructure is all being arranged for you. And the control plane is completely managed by Azure, and you actually also only pay for the worker nodes. You have easy scalability, there's some additional security and governance, and it's obviously very well integrated with the other Azure features like the application gateway and load balancers. So to set up AKS, and that's what my last session was about, you have to do quite some steps. You have to configure your environment, provision a key vault for secure secret management, but also set up your EDS. I'm referring to EDS in this presentation quite a few times too. And EDS stands for External Data Services, or External Data Sources, if you like. And that is the term Sitecore is using to refer to things like SQL, Redis, and Solar. And you have to know that the container setup for your local environment and for production does come with containers for those services. But in production, it's not advised to use those. They are mainly for proof of concepts, demos, and local installations. So you have to provision your own EDS, preferable externally from your cluster, and there's some persistency requirements as well there, because if you deploy a new Sitecore environment, you want to keep your database and your content live, of course. So we looked into deploying those EDS, the Ingress controller, deploying the Sitecore pods, and populating your Solar index. But then you ended up with having a vanilla Sitecore deployment. And we obviously need to take one step more and deploy our own solution. And that's what I'm going to show you today. So in the container deployment process, what do you need to do to launch a Sitecore solution into the clouds? This slide comes up quite a few times. It was also in my last presentation. There's a difference between Docker and Kubernetes. It's both cloud container technologies, but Docker is used for local environments, an easy setup. It isolates your project you're running, and you can quickly start up working on another project if everything is running in containers. And Kubernetes, on the other hand, is focused or aimed at production environments. It has a scripted deployment. It has a very mature container management, and it also utilizes in monitoring, scaling, and the security features that you need in production. But there is also an equal process of deploying those containers, and that's what I want to dive in. Because if you look at deployment locally versus production, everything, of course, starts with the developer and your development environment you're working on. If we look at what happens locally, you probably build via a PowerShell script, and you are going to use the base images supplied by Sitecore, and then run docker compose up to bring up your containers, which results in a set of Docker containers running locally, managed via your Docker desktop, for example. On the other hand, in production, you are going to push those. Oh, excuse me, that was a bit too quick for me. You're going to push your changes to source control. And then from there, you're going to build your solution in a pipeline on, for example, Azure DevOps. That is using the same base images. And then it's pushing those images that you've built into a container registry. We didn't do that last time because we deployed the base images in a vanilla Sitecore setup, but this is one step you have to do when you are going to deploy your own containers. You need a container registry to put your images in, and you're pushing them from your build pipeline into your containers, into your registry. Then you're going to fire up a release pipeline, and based on the version tag, you're going to deploy your cluster or redeploy your cluster. It's based on the Kubernetes spec files, and you're also pushing in the Sitecore content. So you have an updated environment, both in code and content. That AKS cluster is going to pull your container registry images into the cluster based on the version tag you selected in your pipeline, in your release pipeline. And that's the environment your users are going to interact with. If we put them alongside, you see that we're actually using the same base images, obviously, for your local build and the build in your pipeline. But also, you can or are using the same Docker compose process to build your images. And I've heard several times that the advantage of running in containers is that you don't have the issue of it's working on my machine. And there's a difference between production and running locally in the conventional setup, but in Docker containers or in containers, not so much. But I'm not sure if that's the case completely, because it are two different worlds. And the question is, should we reuse the composition? In a demo where you are going to deploy your containers to Kubernetes to see how everything works, of course, you can use the same compose file. But in a real production-like environment, things are a bit different. If you zoom into that, on the left side, we have our local Docker containers running in your Docker desktop, created via your PowerShell CLI. And very important, you're also running containers for your data services, so your Solr, your SQL Server. On the right side, we see a typical setup of a production-ready Kubernetes cluster. It has the ingress controller, you have your node pool, your Windows node pool with your Sitecore pods and all of your worker roles. And then on the right side, you see the external data services like the Redis cache, Solr, and all of your SQL Server databases, which in my case are being deployed in SQL PaaS databases from Azure. And this is all fired up via a pipeline. Within that pipeline, within a CLI, the commands are actually the same, but the resulting environment is different. On the left side, we have containers running for your EDS. On the right side, we don't. The fun thing is you can still, for example, synchronize content via Sitecore CLI to your containers, and you can still use the exact same images. It doesn't matter that, for example, for the CD image, that your EDS are not running containers. It's just working via the connection string, and it's configured differently. We're going to look into that in a bit. So that doesn't matter for your containers, but there are some similarities and differences. So let's compare them. The similarities are that you use the same images for the corresponding containers, CD locally and CD in production. And you use the same scripts for building your containers. Your Compose script, your PowerShell scripts, they are mostly the same. You can still publish your content via the Sitecore CLI, where it's the same, and you interact with the Sitecore instances, so with the CM or the CD. So it doesn't really matter that the database that you provisioned is running in a different technology. On the other hand, we don't have those EDS in the container, so we don't need to build those images in the pipeline when we're deploying to production. That would just be a waste of time. And we also probably don't run the same topology in production. I can't imagine you want to fire up an XP1 topology each time you want to test something out on your local machine. So there's some differences as well. And we only need the Docker environment variables that are present in your Compose file. We only need them locally. So if we are going to fine-tune our Compose file, you see, if you look at the Compose file, you see two areas. The first one is actually building the image, and the second one with the volume mounting and the environment variables is targeted at Docker. And you don't need them in your production pipeline. So what I would say is use separate Compose files or override them, use an override for each environment, because you want to remove unused configuration for clarity. And you also want to remove unused images to build faster. If you look at the complete Compose file and you zoom out a bit, you can see that we have images like Redis and Solar that are, as I told you, we are running in our production environment in a different setup, so not in a container. And also, and this really depends on the topology you're using, but also depends on what you are developing, how your project is set up. If you have custom facets for XConnect, you need to also deploy to XConnect. But if you don't, then maybe you can just deploy base images there. So per role, it really differs. If your project needs to be deploying to those roles, and well, if you can use the base images, that of course is a faster build. So then you want to do that. And when you look at the EDS connectivity running in a container locally and running out of the containers in production, you can see that the environment variables are actually equal to the Kubernetes secrets. So on the left side, we have a Docker Compose file, which supplies you with the connection string in this example for Solar. And you can leave them out, because in production, we are going to retrieve the same connection string from our Kubernetes secrets. And as I showed you in my last talk, you can maybe even better pull them from an Azure Key Vault, because that's even more secure. So put them in your Key Vault, then they get pulled into the in the Kubernetes secrets at release time, in your build time, in your pipeline, and then they are going to be populated when deploying the cluster. So actually, separate EDS is the same either way you're provisioning. And then we need to do a few more things to complete our Compose file and prepare for pushing to our custom ACR. And that is that your image name really has to start with the name of the, in my case, Azure container registry, followed by a slash. So if you look at the pipeline variables, you see that we included the name of the container registry, and also a variable that's called registry with a trailing slash, and that is prefixed to the image name in your Compose file. And you want to do that because this is needed for the image to be pulled from your ACR. So you should get that right. Okay, so now we have prepared and fine-tuned our compose file. It's time to take a look at the pipeline. When extending the initialization for redeploy purposes, we actually need to add in some more steps into the pipeline. And here's the point where the regular demo Kubernetes deployment clearly differs from a real production-like scenario, because, as I said, because we do not run the EDS within a container and we need some persistency across deployments, you're not going to deploy your EDS every time. And you also don't need to run your init jobs if there's no changes in the Sitecore version or anything. So you can leave them out. But we're also missing some steps, because we deployed the basic Kubernetes secrets here, and we did not yet build and push our own images. And that's what we need to add to the process. And really, the EDS provisioning is a one-time job. There's some more things that you can do only one time, like provisioning the ingress controller. But from an infrastructure as code perspective, I would say that most of the pipeline stages should be rerun. So you can push changes by just changing the infrastructure as code that you have. And we're looking to create a repetitive process here. So let's dive in this build and push images task. Oh, one more thing. You can choose to create a new pipeline to initially set up and completely build from IAC your cluster. You can also, and then add a new one for deployment. You can also use stages, and then you can pick which stage you want to run at which time. So that's up to you. But you need to add a few steps. And it's actually two tasks. One task to build your images, and one task to push your images to the container registry. You could possibly do it at once, but you want to have two steps, so you can run builds and check those before pushing them to the ACR, or you can maybe throttle the amount of images being pushed to your ACR if you only want to push builds from a certain branch, or if you want to check if things succeeded and stuff. So you don't, if your build fails, you're not going to push an invalid image or a missing image to your ACR. So you want to split that. And here again, we need to configure our Azure Container Registry, put in our subscription and a container registry. And also, as you can see here, we've used a different Docker Compose file, a YAML file, especially tailored at the Azure DevOps environment that we're using, or the production pipeline. So this is our updated Docker Compose file. And then lastly, we need to change the source in the Kubernetes spec files to point to our Azure Container Registry. Because if you look at the Kubernetes spec files provided by Sitecore, you will obviously find the base image in each container, which deploys your vanilla solution. And now we are going to replace that with the link to our ACR and our image. In this example, I used just the latest version or the latest image. Rob Allen has done a very clear and good explanation of of why and when you should which version tag. And I think you should check that out, because it's important that you do not always get the latest. You have to really configure the right image tag per version. But for this demo purpose, I'm trying to point out that you need to change your image to the right version and to the right ACR. And now we are ready. We can run a pipeline, and this is actually all that you need to do to configure your custom image deployment to the Azure Kubernetes cluster. Also, you need to, as I already mentioned, serialize your cycle content. You can do that with Unicorn, with EDS, but in Sitecore 10, we've got a new tool, and that is Sitecore Content Serialization. And I would say that it is a good idea to look into that, because it's very flexible. It's a rule-based configuration. The configuration and the output format are both in JSON. It has some neat features like aliasing, so you don't have to cope with the issue of the path limit. And it's optimized for the Helix architecture as well as for remote control. So it's very easy, or maybe even the easiest way to run your serialization and deserialization process from both your CLI or from within your pipeline. And the image on your right is one I grabbed from the Sitecore documentation, and you see that the developer can interact with the Sitecore CLI and with your Sitecore management services to synchronize the content. But that actually works the same from your PowerShell CLI and your as it does from your pipeline. So you can see that in this case, you can add one more step to your build process to deserialize your content. And it's one single pipeline task with some very clean and easy to understand commands. Here I've highlighted the Sitecore serialization push, of which Seth is the shorthand, and a cycle publish, which does a full smart publish of your serialized content. And well, this is I think a little bit more stable and more easy to configure, and especially when running in containers. So and so that's one thing to look into. I'm not going to explain the whole cycle content serialization. There's other talks and other videos on the internet of that, but my advice is to change over to that as well when you go into Kubernetes. So I promised to also talk about deployment strategies, and in the past I gave a lot of talks on Sitecore blue-green deployments on Azure PaaS. It wasn't a full blue-green setup, as I most of the times kept the databases running because of the serialization process, often done with Unicorn before. It's very easy to roll forward and to roll back with your content. So we at least didn't really need a blue-green version of our databases, but we do need a staging slot in a Azure Web Apps architecture, because you don't want to have downtime. You want to have zero downtime deployments. So we needed a staging slot to provision that, and then push your new Sitecore version to a staging slot, and then when everything's ready, swap the two, so your site goes live instantly. And that is what I call blue-green deployments in Sitecore. And well, we still want the zero downtime deployments, but how does that work in Kubernetes? Well, it's very simple actually. Kubernetes has some update strategies, and one of the most common and also maybe the default, depending on your setup, is rolling updates. So what is rolling updates? It's a baked-in way of gradually updating your pods. And you actually don't need a separate staging slot for each of the cycle roles. You don't have to arrange anything for that. You can obviously create a blue-green, a real blue-green deployment. So you can maybe create multiple containers with versions, so you can fully bring up a new environment but keep it away from being published. Of course, that's also an option, and for an enterprise setup you maybe want to look into that. But as an easy start, it's very good to know that you don't need to do anything to get this to work, other than in the deployment manifest you have to have the strategy set to rolling update. And you can also indicate how many replicas you want, and if you, well, with how many pods a time you want to update or you want to add, and how many should be unavailable. So for this setup, it says, I want to deploy, I need 3 pods live. I want to deploy 1 pod at a time, and I don't want any pods being unavailable in the process. So what Kubernetes automatically does is, you have 3 pods, it brings one new one up with the new version, and only when that one is up, it brings the old one down. So it gradually replaces the pods. And in the process, let's see that again. In the process, you always have 3 pods being live in the process of a different version. But that doesn't really matter, because when a user switches to the new version, it's going to be instant, and it's going to be arranged by the Kubernetes control plane anyway. So this is how you, as a basic or as a start, do your well, blue-green kind of deployment, because, well, it's obviously not a full blue-green, but it is a good replacement, and even a better replacement of the staging slot principle we had before on Azure Web Apps. But as I said, your pods need to be healthy before coming up, and that is where you come in. You need to do and be sure that your health checks are okay, and then Kubernetes does the rest. So Sitecore by default comes with some health check endpoints. You have the live and the liveliness and readiness health check endpoint, and for each of your roles, but also for the non-web roles, it also works. And as the Sitecore Kubernetes spec files provided by Sitecore already actually are configured to use those. So if you look at the spec files, and you can see that there's a liveness probe and a readiness probe, and they are configured to point to that exact same path or endpoint, and it is configured to being used with some timeouts and thresholds. You can also add your custom health checks. You don't need to, but if you, for example, have a custom API built that needs to be spun up before your web role can be declared healthy, you can do so by implementing the Microsoft Extensions Diagnostic Health Check interface, and you can add health checks to that to make sure that everything's up and running before Kubernetes switches to the new pod, and by doing so, customize and perfect in a way the rolling update strategy. And that wraps it up for today. I've showed you how to deploy to your freshly set up Azure Kubernetes cluster with Sitecore, and what you need to do to configure it to use your own custom ACR. So what's next? I talked about the initial provisioning, about the deployment. In my next talks, I want to dive in onto the monitoring subject, because obviously application insights isn't used anymore, so we need to do monitoring in another way, and also about scaling your Sitecore Kubernetes setup. In the meantime, feel free to browse to my GitHub repository. It's the repository where I publish and share all of my scripts and pipelines to create some kind of Sitecore on AKS boilerplate from that Azure Web Apps perspective that we had before. So if you're transitioning from Web Apps to AKS, then this is the type of scripts and way of thinking you might want to use. It's just one of the way. It's not maybe the best. It's not the only way. Certainly it isn't. But it's one of the ways to set up a cluster and configure everything for production. This repository contains code built by me and my colleague Erik Jeroense, and you can expect to see the pipelines discussed today shortly. So feel free to join in, create issues or pull requests. I like to learn about your experience with running Sitecore on Kubernetes in general too. So please join in. And that was and that is the end of my talk. I want to thank you for joining, and I also want to thank SUGCON for the opportunity for me to share. And if you want to reach out, you can do so on my Slack or my Twitter account. Thank you for your attention.
All right. Thank you so much, Rob. Do we have any questions for Rob? Hey, I'm actually seeing a couple of questions.
Cool.
Yeah, there are a couple of them.
Probably. Rob, if you can see an address.
You mentioned
replicas in your update strategy. Is it okay for CM and CD slots? Yes, it absolutely is. Yeah. How do you scale the Sitecore Kubernetes vertically? Well, as you saw, I wanted to focus today on deploying your custom solution. And one of the next topics I want to dive in is scaling, both vertically and horizontally. Sitecore on Azure or on Kubernetes in general is rather new. So I want to build up some experience with this before I'm going to be able to give a good answer on your question. So for me personally, I can't answer this yet. You mentioned the latest tag strategy in the build pipeline. What about the lower environment, for instance, staging? Same approach. Yeah, well, yes, absolutely. I want to. I would want to have the same approach for all of the environments. I think that it's a good idea if you have a multiple environment setup that you have a representative way of publishing, and you don't always necessarily pick the latest one. And well, I referred to the explanation by Rob Elam. It's quite a long explanation and video on how you can do that, and I don't think I have time to fully go through that right now. But I don't see a reason to have a different tag strategy for your lower environments. question on the blue-green deployments. What's the strategy followed on the content dependency of your new release? Well, that's an interesting question. For me, it's been the same strategy for a few years now. If you want to run multiple databases, so blue-green on your database as well, you actually also need blue-green on your indexes, because, well, if you're going to have two web databases in Sitecore, your index is still being built up on your master, and you are going to have some items in your index that do not refer to any content, some maybe an off an index entry. So if you want to really do blue-green on your content, on your databases, you have to fully replicate the whole stuff. So the indexing, the databases, and it's quite cumbersome. Also maybe a bit more expensive for a lot of customers. It gets pricey very quickly when you run the full topology twice. So if you look into it, you really don't need to have blue-green deployments in your Sitecore production environment, because you have the content that is synchronized with the Sitecore CLI or with Unicorn, and you can synchronize to a new version. But if you roll back to a previous version, the state of your content is determined by your code, by your source code. So you can actually just roll back, and the content will be rolled back as well. And then you only have the issue that if you are going to remove some template, for example, that while your content is already being changed, or maybe not yet, that's a racing issue that you have there, and your pods are being updated, you can have some issues there. But that's something we take care of in the process. If you always only add new functionality within your Sitecore templates, within your Sitecore layouts, then you never have an issue rolling forward, because the V1, the old pod, is still only seeing the template fields that he expects, and the version 2 is once it comes up, it's immediately seeing the new fields. If you want to remove something, well, it doesn't occur a lot, so it's maybe a one time in a year event, or maybe twice if you want to get stuff out of your database. Then you simply can cope with this by publishing new stuff in one release and removing other stuff in the next release. And that way you never have a breaking change in regard to your content. So that's the content strategy, the content dependency strategy that we use for quite some years now, also in the Azure PaaS architecture. And I don't think that changes for the cluster, for the Kubernetes cluster. Is it possible to use Terraform to provision Sitecore on AKS? Probably yes. I am only experienced in ARM myself, so I can't give you any pointers on how to, but I don't see a reason why it's not the case. The deployments is mostly the CLI commands you also see in the Sitecore manual, and the thing we use ARM for is actually the EDS. So setting up Azure SQL, for example, or setting up a VM to run your solid cloud in your Zookeeper. I don't see a reason why that can't be done in Terraform. So I think yes, but again, I'm only experienced in ARM myself. Is it good to go with SaaS Solar or Kubernetes-based instance? Yeah, I think with SaaS Solar, yes. A Kubernetes-based instance, I don't know. We run our Solar cloud separately, and we do that on our own managed environment. So I don't think from the cluster perspective there should be a difference between SaaS and a VM that you're running yourself. I do know that Sitecore doesn't recommend to run Solar within the same cluster and the containers they provide. What's the disaster recovery strategy in terms of geolocation, resource sizing, and compared to prop and data replication? That's kind of a lot of questions in one. And I think this also mostly concerns scaling. And for time purposes, I would say that I get to those next time. And it's also more of a general Kubernetes question, I think. Yeah, Kubernetes is self-healing, and for terms of disaster recovery, if you just roll back, or you just if some containers get corrupt, they will be renewed automatically. And in terms of scaling, I'll get to that. What strategy to fully utilize the pods? I really don't get the question. Sorry, that's maybe me, but. No, sorry, I'll answer it.
All right.
Thanks.
That's actually a lot of questions we got for your session. Thank you for addressing all of them. And I think the remaining questions are all, appreciation for the presentation.
Nice.
Yeah.
Thanks a lot.
All right.
Thank you, guys.
Thank you so much for the presentation. All right.
Thank you very much.
Okay.
All right. I think Amit, the one who had the most number of questions, he's going to reach out to you offline. So that's good.
Okay.
You guys can have a discussion
That's
about
great.
that.
Yeah, absolutely. Yes, that's okay.
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 Great. Thank you so much for taking the time.
My pleasure. And thanks for the opportunity. And I'm going to hop off the stream right now. So,
right. Bye.
Bye.
Now is the time for solidarity in the face of this threat to all of humanity. I implore leaders to stand together and heed this appeal.